Good morning, students. Well, already so far we discussed about the first unit, that is introduction to signals and systems. Okay, so now we are going to discuss about the second unit, that is Fourier series and Fourier transform. So the topics involved in this second unit, that is Fourier series and Fourier transform, are Fourier series representation of continuous time periodic signals, properties of Fourier series, and again Dirichlet conditions, trigonometric Fourier series and exponential Fourier series, relation between trigonometric and exponential Fourier series, complex Fourier spectrum, deriving Fourier transform from Fourier series, okay, Fourier transform of arbitrary signal, Fourier transform of standard signals, Fourier transform of periodic signals, properties of Fourier transforms, Fourier transforms involving impulse function and signal function, and finally the introduction to Hilbert transform and some related problems. These are the topics involved in this Fourier series and Fourier transform. Next, coming to the Fourier analysis. What is meant by Fourier analysis? Fourier analysis is nothing but it is a useful tool for representing the signal as well as the analyzing the system performance in frequency domain, not time domain, in frequency domain. So representation in frequency domain is very easier when compared with the time domain. So here Fourier analysis is a useful tool for representing the signal as well as the analyze the system performance in frequency domain. Here mainly the signal characteristics can be represented in terms of amplitude spectrum and phase spectrum. What is meant by amplitude spectrum? Amplitude spectrum means amplitude versus frequency. We will plot the graph between amplitude and frequency in amplitude spectrum. Coming to the phase spectrum, we will plot the graph between phase angle and frequency. Next, frequency domain analysis of systems provides many advantages over time domain analysis of system. Like suppose if we take convolution, we already discussed about the convolution in our first unit. So convolution in time domain becomes simple multiplication in frequency domain. So frequency domain analysis provides many advantages over time domain analysis. So like convolution in time domain becomes simple multiplication in frequency domain. Just if you multiply the two components in frequency domain, whereas if you do the convolution, we have to do the convolution in time domain. Okay. Next, coming to the periodic signal representation by Fourier series. Here we have two forms of periodic signal representation of Fourier series. Those are trigonometric form and exponential form. First one is trigonometric form, and second one is exponential form. Okay, coming to the trigonometric form. So let us derive the trigonometric form and its coefficients. Okay, so let m of t, generally we take m of t be an arbitrary periodic signal, periodic continuous time signal. So it is represented as m of t equal to m of t plus t naught. Why? Because it is periodic signal. That's why we are representing m of t as m of t equal to m of t plus t naught. Let it be considered as equation number 1, where this capital T naught is called fundamental period. So if T naught is the fundamental period, then fundamental frequency is nothing but reciprocal of its fundamental time period, that is f naught. So f naught equal to 1 by T naught. So any arbitrary signal m of t can be represented as combination of DC component and AC component. AC components means sinusoids of fundamental frequency f naught and its higher harmonic. So if you take any arbitrary signal m of t, which can be represented as the combination of DC component as well as sinusoids of fundamental frequency f naught and its higher harmonics 2f naught, 3f naught, 3f naught, 4f naught up to nf naught, etc. Therefore, we can write this arbitrary signal m of t as a combination of DC component as well as arbitrary sinusoids of fundamental frequency f naught to nf naught. So m of t is equal to a naught plus a1 cos 2 pi f naught t plus a2 cos 2 pi f naught t plus b1 sin 2 pi f naught t plus b2 sin 2 pi f naught t, etc. So where omega naught or 2 pi f naught is nothing but angular frequency in radians. Okay, omega naught equal to 2 pi f naught. So we can write this as m of t equal to a naught plus sigma n equal to 1 to infinity an cos n omega naught t plus bn sin n omega naught t. This whole combination can be written as a naught plus sigma n equal to 1 to infinity an cos n omega naught t plus bn sin n omega naught t. Let it be considered as equation number 2. Okay, so this equation number 2 is periodic with fundamental period t naught. Okay, periodic with fundamental period t naught. So let us take m of t, the arbitrary signal m of t, which is a periodic signal. So it can be represented as m of t equal to m of t plus t naught. So any arbitrary signal can be represented in terms of DC component as well as AC components like a naught plus sigma n equal to 1 to infinity an cos n omega naught t plus bn sin n omega naught t. Okay, so from equation 1, a naught, an and bn's gives the following relation. So what is A naught? A naught is nothing but the amplitude of DC component. What is ANs? ANs are nothing but amplitudes of corresponding cosine components. Why? Because this is AN cos n omega t, right? So ANs are amplitudes of corresponding cosine components, and similarly BNs are amplitudes of corresponding sine components. Okay, these are determined by using the formulas A naught equal to 1 by T naught into integral T naught to T naught plus capital T naught m of t dt, whereas an equal to 2 by T naught into integral T naught to T naught plus T naught m of t into cos n omega naught t dt. Similarly, bn equal to 2 by T naught into integral T naught to T naught plus T naught m of t sin n omega naught t dt. So the trigonometric Fourier series expansion of m of t can be expressed by the equation m of t equal to a naught plus sigma n equal to 1 to infinity an cos n omega naught t plus bn sin n omega naught t. This can be written in polar form. For our simplification purpose, this above expression can be represented in polar form. Polar form means magnitude and phase angle form. Okay, so in polar form, which is more compact and meaningful representation, which is given below, that is m of t equal to s naught plus sigma n equal to 1 to infinity Sn cos n omega naught t minus phi n. Okay, this is the polar form of the above expression for our simplicity. So we are writing this. So this is very simple form and more compact and meaningful representation. It will give the meaningful representation. So m of t equal to s naught plus sigma n equal to 1 to infinity Sn cos n omega naught t minus phi n, where s naught equal to a naught. This s naught and a naught both are equal, and Sn equal to, this is the square of the an square plus bn square magnitude, square of the n square plus bn square, and phi n is minus of tan inverse of bn by an. These are the polar forms representation of the above expression. Okay, so this is about the trigonometric form of the periodic signal, periodic continuous time signal m of t. Okay, so s naught equal to a naught, Sn equal to square root of n square plus bn square, and phi n is minus tan inverse bn by an. So let us prove this. So here m of t is given as a naught plus sigma n equal to 1 to infinity an cos n omega naught t plus bn sin n omega naught t. Okay, so consider any arbitrary internal interval of signal m of t, that is m of t equal to an cos n omega naught t plus bn sin n omega naught t. Divide and multiply this RHS, that is an cos n omega naught t plus bn sin n omega naught t by square root of an square plus bn square. So it is equal to an by square root of an square plus bn square into cos n omega naught t plus bn by square root of an square plus bn square into sin n omega naught t whole into an square plus bn square. Let it be considered as equation number 5. Okay, so with the an, bn and square root of an square plus bn square, right angle triangle will be formed with the 90 degrees angle. So this is an, this is bn, and this is the square root of an square plus bn square. From this sin theta equal to bn by square root of an square plus bn square, and cos theta equal to an by square root of an square plus bn square. Now this equation 5 will become m of t equal to see, this is an by square root of an square plus bn square is nothing but cos cos theta or cos pi n. Similarly, bn by square root of an square plus bn square will become sin pi n. So substitute the values of cos pi n and sin pi n in this equation, so that it will become cos pi n into cos n omega naught t plus sin pi n into sin n omega naught t whole into square root of n square plus bn square, right? So it will become m of t equal to cos n omega naught t minus pi n into Sn, where Sn is nothing but square root of n square plus bn square. Okay, and phi n is nothing but minus tan inverse of bn by an. So this is equation number 6. So this equation number 6 indicates that the time domain signal m of t can be represented in frequency domain by its amplitude spectrum as well as phase spectrum. As we already discussed earlier, that amplitude spectrum is represented as the plot between amplitude versus frequency, and phase spectrum is represented as the plot between phase versus frequency, right? So here A0, An and Bn are called Fourier coefficients. These three are called Fourier coefficients in the trigonometric form of our periodic signal C of t, periodic continuous time signal M of t. Okay, so A0, An and Bn, these are called Fourier coefficients of the trigonometric form, right? This is about the proof of our trigonometric form of our continuous time signal, continuous time periodic signal, right? So here we have to calculate the values of A0, An and Bn. A0, An and Bn. Okay. So now we will see some problems related to this trigonometric form of the Fourier series. Okay. See, see the problem. Draw the amplitude and phase spectrum of the time domain signal m of t, which is as shown as like this. This is the given diagram. See, this is given as e power minus t, m of t equal to e power minus t. M of t is given as e power minus t during the interval 0 to 1. It is the given problem. Okay, it means that the fundamental period t naught will be 1 second. See the diagram. In this diagram, from 0 to 1, this will be denoted as t naught. Okay, so it means that t naught will be 1 second. What is F naught? F naught means fundamental frequency. It is nothing but the reciprocal of our time period, fundamental time. So it is 1 by 1, that is 1 Hz. 1 Hz is the fundamental frequency. So by knowing the fundamental frequency, we can find out the angular frequency. Angular frequency means omega naught. Omega naught equal to 2 pi into f naught. Okay. So 2 pi into how much will be the f naught calculated? That is 1 Hz. So 2 pi into 1, that is 2 pi radians. So omega naught will be 2 pi radians. Okay. So now the signal m of t. What is m of t given? M of t is mathematically represented as m of t equal to e power minus t during the interval 0 to 1. 0 to 1. For 0 is less than, t is less than 1. Okay. So m of t equal to like this, e power minus t. M of t is e power minus t for 0 is less than, t is less than 1. So Fourier series expansion, how it is given, that is m of t equal to a naught plus sigma n equal to 1 to infinity an into cos n omega naught t plus bn into sin n omega naught. This was already discussed. We already know this. Okay, so that is m of t equal to a naught plus sigma n equal to 1 to infinity an cos n omega naught t plus bn sin n omega naught. So to sketch the amplitude spectrum and phase spectrum, we have to calculate the Fourier quotients. What are the Fourier quotients here? So here the Fourier quotients are A0, An and Bn. We have to calculate these parameters first. Okay, A0. So by using the formulas, we have three formulas are there. How to calculate A0? A0 equal to 1 by T0 integral T0 to T0 plus T0 m of t dt. Similarly, an equal to 2 by t naught integral t naught to t naught plus t naught, okay, cos n omega naught t, right? And Pn is 2 by t naught into integral t naught to t naught plus t naught sin n omega naught t dt, m of t into, okay. So like that, we calculate those parameters first, okay. So we calculate these parameters. So see a naught equal to 1 by t naught integral t naught to t naught plus t naught m of t dt, right? Now, what is m of t value here? E power minus t. Okay. So here the limits are from 0 to 1. So 1 by t naught. How much will be the t naught? 1 second. So 1 by 1 into integral 0 to t naught plus t naught. 0 plus 1, that is 1. E power minus t dt. So e power minus t, e power minus integral e power minus t is nothing but minus e power minus t. Okay. With limits 0 1. So that we will get 1 minus e power minus 1 is the a naught value, right? A naught is, so by simply calculating this e power minus 1 value and subtract it from 1, so that we will get 0.632 is A naught value. Next, how to calculate an value, that is 2 by t naught integral t naught to t naught plus t naught m of t into cos n omega naught t dt, right? So what is omega naught? Omega naught value here, omega naught value is 2 pi radians here. So 2 by 1 into integral 0 to 1 e power minus t into cos 2 pi n into t dt, right? So, but we have the integral formula, that is since integral e power ax into cos dx is equal to e power x by a square plus b square into a cos dx plus b sin dx. So the above formula is in this formula, right? So apply this. So it is equal to 2 into e power minus t by e power ax, that is a value is minus 1. So e power minus t by minus 1 whole square a square plus b square is 2 pi n whole square, okay, right, into a is minus 1 into cos 2 pi nt plus 2 pi n into sin 2 pi nt with limits 0 1. By simply substituting this, we will get the value of an is 2 by 1 plus 2 pi n whole square into e power minus 1 plus 0 plus 1 plus minus 0, that is 2 by 2 into this value is already calculated, that is 0.632, 2 into 0.632 by 1 plus 2 pi n whole square. So this is the Fourier quotient an value, right? Next, in the same manner, we will calculate the bn value also, that is 2 by t naught integral t naught to t naught plus t naught m of t into sin n omega naught t dt. So it is m of t is e power minus t. So it is also in the above formula. So it is calculated. That formula is integral e power x into sin bx dx is equal to e power x by a square plus b square into a sin bx minus b cos bx. So apply this in the above formula, so that we will get the value of bn is 4 pi n by 1 plus 2 pi n whole square, right? 4 pi n by 1 plus 2 pi n whole square into e power minus 1 plus 1 or 1 plus e power minus 1, right? So 1 plus e power minus 1 value is nothing but 0.632, right? So it is 4 pi n into 0.632 by 1 plus 2 pi n whole square. Like this, we can calculate these three Fourier quotients values a naught, an, and bn as a naught equal to 0.632, an equal to 3 into 0.632 by 1 plus 2 pi n whole square, and bn is 4 pi n into 0.632 by 1 plus 2 pi n whole square. Now we will substitute these values in the expression, frequency domain representation of m of t, that is m of t equal to a naught plus sigma n equal to 1 to infinity an into cos n omega naught t plus bn into sin n omega naught t. So an value is 2 into 0.632 by 1 plus 2 pi n whole square. Bn value is 4 pi n into 0.632 by 1 plus 2 pi n whole square. And a naught value is 0.632, right? Now we can calculate the amplitude and phase spectrums, right? So and now it can be converted into compact form. For our convenience, it can be converted into compact form, that is m of t equal to s naught plus sigma n equal to 1 to infinity s n cos n omega naught t minus phi n, where s naught is equal to a naught equal to 0.632, right? And mod Sn is, it is nothing but amplitude, that is square root of am square plus bn square. Okay, so by simply substituting these values in this above expression, we will get mod Sn equal to 2 into 0.632 by 1 plus 2 pi n whole square into square root of 1 plus 2 pi n whole square. So it will become 2 into 0.632 by square root of 1 plus 2 pi n whole square. Similarly, phase angle pi n can be calculated as right. So pi n can be calculated as minus tan inverse of bn by an. So simply substituting the bn and an values here, so that it will become minus tan inverse 4 minus tan inverse 2 pi n, right? 2 pi n. So already magnitude value is there, phase value is there. So Sn equal to mod Sn equal to 2 into 0.62 by square root of 1 plus 2 pi n whole square, and pi n equal to minus tan inverse of 2 pi n. Now we can draw the magnitude and phase spectrum. So the amplitude spectrum, first of all, this is the amplitude spectrum and this is the phase spectrum. How to draw the amplitude spectrum? By taking these values n, omega and mod s. So if n is 1, 2, 3, so
Amai, what do you drink?
yeah.